time to welcome him. Dan is affiliated both with the IMC but also the Cognition and Behavior Lab here in Aarhus. Don't be shy. I know there's a few chairs like spotted around at the back. Feel free to jump this one up the front here. Grab some coffee. You know, it's all quite flexible and relaxed. And one of the great things about the Cognition and Behavior Lab is that they've got a fantastic setup to do a lot of participatory research experiments, but they also have a lot of technology. And some of this technology is developing at a very rapid pace. And one of the things that Dan and various other people here at the IMC and I have been doing is doing an assessment of, you know, how useful are they? Are they useful in diagnosis? Can they be relied upon in research? Because the different levels of data that are generated seem to vary a lot between different disciplines, and as the technology develops, it can be very hard to assess. Can we? Is this something that can be useful in diagnosis? Yes or no? How much can we trust the technology? And Dan is going to be telling us about a few specific studies he's been involved with, and we'll also point hopefully to the biopack which he's brought with him. Without further ado, Dan and Sarah, everybody.
Well, thank you very much for the nice introduction. So yes, I'm going to talk about a series of studies we did. It was really one experiment, but we analyzed the data over several times. And so it was, I'll explain the study in a little bit, but it was about arousal. So a little disclaimer, I wouldn't coin myself as a stress researcher, but I think what I'm presenting is relevant to a lot of what you guys do. That's my hope at least. So I've got two aims with my presentation today. First of all, I want to show you some examples of research where we use these physiological measures, and maybe now is where I should flash the equipment. Juki asked me to bring it along, so this is like the basic system or part of it that we use to record these physiological measures, and I'll say a little bit about it later, and then in the coffee break you can come up and take a look. So we looked at skin conductance, we looked at several measures, but I'm going to focus on skin conductance because that is a relevant proxy for stress. The other aim that I want to give here is about analyzing group level data, because this is a non-trivial thing, and I'm sure the ones of you who have done it know about this. And specifically, I will show you the different kinds of results we get by aggregating in different ways. We can aggregate from individuals, so taking some sort of individual measure and aggregate that to the group level. We can look at dyads, because there are lots of methods for looking at dyadic interactions. This is the interacting mind center, so of course this is an interaction study. So there are lots of methods here where you can look at dyads, and then you can try and aggregate the dyads to a group level. And then thirdly, I want to just very briefly at the end show you some results of trying to make what happens if you try to analyze the data at the group level from the beginning, so there's actually no aggregation at all. So a little bit about skin conductance. As Kan Johannes said, this skin conductance is basically you measure the conductance of the skin, but not just anywhere on the body. We have specific sweat glands in two places, on the palms of our hands and fingers, and then under the soles of our feet. And these are called eccrine sweat glands, and they're innervated by the sympathetic branch of the autonomic nervous system. And it can serve skin conductance as a proxy for attention. Could be attention to something external, it could be attention to some thought you have in your own mind. It can be a proxy for stress and also for affect, so different emotional states. How do we measure it? Oh, wrong. This is the one. How do we measure it? It's very simple. We basically just attach two electrodes. This is what's shown here. So two electrodes usually to the fingers of the non-dominant hand. So the dominant hand is free to do some other task. It has relatively high reactivity. What does that mean? That means when you do something, people actually react. You can see it in the skin conductance. This is actually a recording from one of our experimental sessions of one particular participant. And what we see here is this is actually where we take a baseline measure. So there's a 5-minute rest period where we just ask them to, sit and don't talk. They're welcome to close their eyes if they want to. So we see their skin conductance goes way down. This is actually the lowest during the whole experiment. And then once the experimenter says, okay, and I will now we are over, and I will start giving you instructions, then it actually skyrockets. But there are lots of small spikes in between. So it's very reactive, and these spikes can be triggered usually by something in the environment, other people, or it can be something going on in your mind or stress. So this is good. It's simple. It has high reactivity, so it's easy to elicit a response. It's a rather slow response, so it has a lag of a couple of seconds, which may in some situations be a challenge because you don't get like perfect timing. And it's also rather unspecific. You don't really know what it is that the person reacts to, why the skin conductance goes up or down. So this boils down to having a tightly controlled experiment. So designing a good experimental regime. So if you do that, you have a better idea of being specific here. Okay, this is what we ask people to do. So when I say group, it's groups of 3 people. So we had groups of 3 people. We set them up in this assembly line where they had to produce origami boats. So we gave them small pieces of rectangular paper. We trained them how to fold specific boats, and then they had to produce as many boats as possible. So this is it's not a social psychology study, it's more like an organizational behavior or organizational psychology study. And we were, of course, interested in how they performed, and I'll get back to some of the measures. But if you look closely, you'll see that they had electrodes on their cheeks, and this is because we measured electromyography, so we could actually quantify how much they smiled and when they smiled, and also how much. If you look very carefully, it's actually hard to see here, but there are also some wires going like over her ear, and that's because we also measured the activity of the corrugator muscle, which is basically when you frown, that becomes active. And then we also had electrodes placed on their upper body for electrocardiogram, and you will notice there are no electrodes on their hands. That's because they have to be able to use both hands. So we actually placed the skin conductance electrodes under their feet, which is perfectly valid. Okay, so what did we do to them? This is basically a timeline of the whole experiment. So, well, to begin with, they came into the room, we had to attach all these electrodes, and after that, which probably took longer than I've shown here, but it's just a schematic, then we had the baseline period here, where we asked them to relax for about 5 minutes. Then they were given instructions about the experiment, what they were going to do, and they were allowed to practice folding these origami paper boats for about half an hour or so, under the supervision of an experimenter. And then came the real, the task we wanted to, where we got the data from. There were 5 production periods, and each had a duration of 4 minutes. And during those 4 minutes, they had to produce as many of these boats as a team, as many boats as possible. And there was also a quality control, so they couldn't just fold something and say this is a boat. Afterwards, they would be judged, and there would be quality control. Is this a good boat? Is it able to stand on its own? Are the folds nice and symmetrical, and so on? But crucially, we did something to them. So after the 3rd production period, they were told that, okay, the R&D department, this was like in an organizational setting, so the R&D department has come up with a new technology that might be superior to the production technology you're currently using. So this was a new routine for folding the boat. And it was introduced in a video by one of our research assistants. So she would, for the female groups it was a woman, for the male groups it was a male, so we had a gender balance. So she would show them how to make this new boat, very specifically with all the folds, but they would not get to practice doing it. And then afterwards they had to make a decision, okay, do we now want to try this? It was obviously more efficient because it had fewer folds than the one they had been trained to do, but it was also a little bit risky because it included some folds they hadn't been taught, and some of it had to be done like in the air, where you had to make a very complex reconfiguration of the boat. But if they could do that, then it was quite obvious that it would be more efficient to use this new routine. Okay, so what did we measure? We had a battery of questionnaires. we 3 times during the experiment, we asked them about how they felt right now. So we gave them 28 emotional terms like astonished, afraid, alarmed, angry, annoyed, aroused, bored, calm, and so on, in alphabetical order, and then they had to like indicate on a scale from 1 to 5 to what extent they felt like this right now at that particular moment. And we also had a questionnaire at the end about how they perceived the cooperation in the group, how much they liked working with the other people, whether they thought cooperation went smooth and they worked as a team and so on, and whether they liked the other participants. So we had some questions there to assess the quality of the cooperation. Then we did these electromyography measurements. I'm not going to say much about them, but basically they measure muscle activity here in smiling and frowning. We measured skin conductance under the feet, and we measured an electrocardiogram. So basically, all we used this for was to get the heart rate. So basically, the timing between these peaks. But the nice thing about having the whole EKG was that we can actually, if there was noise, we could go in and correct, and even though there was noise, we could filter it out, and we could manually say, okay, this is where the peak is, and then we could salvage some of the data, because when people move, it actually influences these. It's much easier if they lie in a hospital bed, but they didn't. All right, so this was about emotions and the influence of emotions on group decisions, and also then what happens when they do take that decision, how does that influence emotion? So the causality goes both ways, so to speak. We were not interested in particular individual emotions, so we tried to make things as simple as possible, and that's why we use this so-called circumplex model of affect that was introduced way back in the 70s, I think, by Russell. And he found out that to a good approximation, you can reduce emotional space to 2 dimensions. You can also go for, it's a dimensional reduction technique. You can go for 2 or 3. 2 is the lowest number. And if you have 2 dimensions, they're usually interpreted as valence. So this is a horizontal axis. Valence means, is it positive or negative? Is this a positive emotion? So here we have happy, glad, satisfied, content. Or negative, miserable, depressed, frustrated, annoyed, and so on. The other axis is usually interpreted as arousal or activation. So up here you will have aroused, excited, alarmed, afraid, down here droopy, tired, relaxed, which are inactive emotions. Okay, so one other thing we did though was we induced people, we had a manipulation, so we tried to make them either positive and active up here or negative and inactive. And this was done by having, we trained our experimenters. One of them was an amateur actor, and he had taken acting classes. And so this is a method that's actually been used, so it's well described in the literature. So they would do like particular, they would be more energetic and move their arms. So I'm in the positive active quadrant, but I could also be in the inactive negative. And that would probably maybe affect you. At least it would be more boring to listen to me. So we did a manipulation check, and this worked initially. So even though this was an effect throughout the experiment, which lasted about, well, over an hour, then we saw that unfortunately our manipulation wore off as they started to become engaged with the task. And specifically, we succeeded in splitting them between positive and negative, but the active-inactive manipulation didn't really work. And we'll see this later in the data as well. Okay, so the first study, which was like a traditional organizational behavior method study that we did put in the psychophysiology measures, which is not traditional, but other than that, we were like, this was from the outset, it was thought of to be like a traditional study, but with the addition of psychophysiology. This is published in Strategic Management Journal. Yes, so we had a couple of hypotheses. I'm just going to run through them briefly. I won't go into a lot of details. But one was that so we framed it as sort of they could make 2 decisions, right? We introduced a new technology, and we were interested in this group decision. Did they go with the new, better method, way of folding the boats, or did they stick with the old one? So if they go with a new one, that's called exploration, and if they stick with if they go with the new one, it's exploration. If they stick with the old one, it's exploitation. So you exploit what you've already achieved and try to just do what you're already good at, whereas if you're explorative, you seek out new methods, new terrain. And exploration versus exploitation is two different modes of behavior that we also see in animals foraging for food, in companies, so it's a very widely used dichotomy. So one hypothesis we had was that performance would probably be a key driver of the decision to explore or exploit. So if you go down in performance over time, then you know you're actually not doing very well, or you're maybe just flatlining, and then you're more likely to explore. That was the hypothesis. The other hypothesis, and this is based on literature and other experiments, was that positive emotions would make people more likely to explore. And remember, we did succeed in actually manipulating people to be either more positive or negative. The third one, if you do explore, if you do adopt the new routine, then you will probably have an increase in positive emotions, but that's going to be mediated by the performance change. Why are you happy with it? Well, you're happy because you succeed, because you also become more productive. It actually, you not only did it, but you did it well. And just to spoil everything right now, here are the results. We actually confirmed most of our hypotheses, but strangely we did not see, well, okay, so we had some like borderline significant, but I don't like that term, so so I'm going to say we did not have support for this this hypothesis. But just to show you that it's relatively easy to see from the data that performance is actually sort of driving the decision to explore or exploit, and the statistical analysis also backs this up, but I'm just going to show it to you graphically. So this is a list of all the groups we had. We had about, I didn't mention that, but we had about 50 groups, 51 I think, and groups of 3, so that was 153 participants in total. And I've split the groups into 4 categories. The first one, and I'm doing this according to what I call adoption profile, and this is whether they adopt the new procedure or not. So adoption here means what do they do after trial 3, where they've seen the new technology? Do they choose to adopt it in trial 4 or 5? Here they don't, so they get 0, 0. Here they do in both 4 and 5, so they get 1, 1. Okay, 1 means they do the exploration, they adopt the new routine. So let's look at this one. What we see here is this is performance measured in the total number of boats. We see some group was really bad. They didn't make any boats in the first, and they probably, this is the same group. I don't know, but then they only make 1 per. That's pretty bad. But in the average is this red line here. So we see the average grows, but only slightly so. So let's compare it to this one then. Here we see that they actually see it's only 4 groups, right? So it's a very small sample. This was 6 groups. Most of them actually do the adoption. But in here we see that there's an increase, then a decrease, and that decrease is actually what makes them switch, although they shouldn't have done that, right? Because they're even worse off than before. Here we see the reverse. They actually, so there's an increase, they actually try to switch, they're not successful, and then they switch back. And these are the successful ones. And notice the difference in scale. So here it's up to 8, 5, 4, but this is, so the most productive made 12 in the last round, whereas the least productives, well, they made 0. So we had a large variation in productivity among the groups. Okay, so that was just basically a graphical explanation of that one hypothesis that we confirmed. So what did we do here? Now I'm going on to the aggregation part. Like, how do you actually analyze group level data? So what we did here was we took individual scores, normalized. This was both self-report and physiology. So we took individual normalized scores and then we aggregated them to the team level, basically taking a group average, right? That's easy, and you can use multi-level models and stuff. But the thing is, we didn't see any effect of emotion. So, and when I say emotion, it can either be self-report. I'm going to be more specific later on, but it could also be the physiological proxies of emotion, like for instance skin conductance, which is a proxy for arousal or activation in this case. So we didn't see any effect here, except these like marginally significant things that I'd rather not mention. I keep saying it, so now I'm going to stop. All right. We were sort of happy, and in another way we weren't really happy, because we thought we'd seen something in the experiments and the videos and the data that didn't really seem to be there in the statistical tests. So we went back and we were inspired by other people in the Interacting Mind Center who were starting to look into something called synchrony, like synchrony between people in religious rituals, where they could see synchrony in heart rates, and so we thought, well, maybe we can see this in our data as well. So here's an example of what you might call behavioral synchrony. They all have the same posture. They do again. This is from the pilots, so there are no electrodes in this. We also saw that this is a rather busy plot. It was really not made for public dissemination, but I've taken it anyway. So this shows 3 people, 1, 2, 3, in 3 different colors over the whole experiment. So this is the baseline period, that bar, that vertical bar here, and these are the 5 production periods. So there's a larger gap between 3 and 4, because this is where we introduced new technology, where they saw a video introducing the new routine. So, and this is skin conductance. So again, we can see that they tend to co-vary, more or less, right? Now the horizontal thick gray line here is the average between any 2 adjacent vertical lines. So maybe look at these, and we can see that they go up, they go slightly down, they go even more down, and this pattern seems to be consistent among all 3 participants. So that's also something we noticed. Maybe there's some kind of physiological synchrony going on here. This is just qualitative, right? Just looking at the data and thinking, there might be something here. This is heart rate. We see more or less the same thing. And this is EMG of the zygomaticus muscle. So here we see people smiling a little bit and then later smiling a bit more. And they do it at the same time, right? And it's not because we tell them to. So smiles really are contagious. Right. So, but then we wanted to try and see if we could study this in a more systematic way. And by looking at this synchrony, or as we also called it, interpersonal dynamics. So now we were no longer interested in the level, like how happy are people, or how high is their skin conductance, but we were interested in to what extent they co-varied, like were they in sync, right? So that's what we tried to quantify, and so you can quantify synchrony in various ways, and it's been done in various ways in the literature. We used a method that's been used quite a lot here in Aarhus by now called cross-recurrence quantification. And I'm going to try and explain, or give you an intuitive feeling at least, for what that is. It would take about an hour, I guess, to explain it in detail. But think of it like the way I introduced it here, that when one goes up, the others go up, and they go up and down it doesn't have to be exactly at the same time. There can be in time lag. So if any of you have worked with cross-correlation, it's a little related to that, but it's more general. Anyway, first hypothesis was we didn't really have a control group here, because this is like an add-on analysis of the data. So the study was not really set up to do this kind of thing. So we didn't have a control group. Now we tried to construct one, and so we had diets in the groups, like 3 people sitting together. From 3 people, I can make 3 different diets. So if you're 3 people at this table, I can pair you with you, or I can pair the 2 of you, right? So I have 3 diets in a group of 3 people. So, and these are the true diets. Then I can make some what we call pseudo diets, which is I can take say you're working on a task together, you're also working on a task together, but you're in different rooms or at different times, and then I can pair you with you. I mean mathematically, not in any physical sense. And those are the pseudo diets. So they act as a kind of control group, and we try to make them as similar to the true diets as possible. So same time of day, same gender, same manipulation, same adoption profile, and so on. We made everything the same, except these were people who were not in the same room at the same time. So we construct like some pseudo diets. And yeah, so synchrony in these should be higher than in those. I mean, if it's not, then we can just throw away the measure, then it's not really valid. And we found that it was indeed for the psychomaticus and also for skin conductance. But we couldn't see it in heart rate. I mean, the effects were so small that it wasn't significant. And so we threw away the heart rate measures, and we threw away the corrugator data. And probably in the corrugator, it was because we had lots of missing data in the data set because the electrodes came loose. So this is basically just a test of, does this work? The other hypothesis was, okay, we think that groups that are more in sync probably have a better perception of their teamwork, their cooperation. So these are self-report measures of cooperation. That's the questionnaire we did at the end. So we hypothesized that sync is positively correlated with this perceived quality of cooperation. And then we had a more exploratory question, like, is there any way we can use synchrony to predict or whether they choose one or the other decision? That would be kind of cool if we could, but we didn't really have any clear hypothesis. We had nothing to base it on, really. So this is what we did. Just looking at the data here, by the way, this is skin conductance again, 3 different people in 3 different colors. It's a 2-minute segment from the beginning of the study. This is actually literally the first data I grabbed when we discussed this and say, okay, let's take a look at that. Okay, I took like one of the first groups we did, and I just looked at like some of the initial first 5 minutes, and then I cut something off in the beginning here so we don't see everything. And this is what came out. So this is not cherry picking. This is like it's not even a lucky draw. It's just the way the data are. So here, skin conductance is of course has units and so on. But in order to be able to compare between people, we normalize them because people react in very different ways, depending on age and gender and time of day and even race and other parameters. So we normalize them here, and here they're normalized to be between 0 and 1. Later on, I'll use a different kind of normalization. But what we see here is that they actually all go up at the same time around here. This is actually at the end of the baseline when the experimenter said, okay, now I'm ready to give you instructions. And then it went up. But we also see that the way some of the finer details, like, okay, this goes up here, that goes up here, this one also goes up, they seem to co-vary. So this is where I'm going to give you a 5 minutes, sure. I'm going to give you a very brief, intuitive feeling for what this cross recurrence analysis is about. So basically, I've just taken 2 of the people here, so red and blue, and now they're normalized as z-scores, so we have negative values as well, but it's just a different normalization. So here we see that they actually lie not perfectly on top of each other. That would be remarkable if they did, right? Truly remarkable. We're talking about people here, not about molecules or machines. But this is how 2 different people react in the same situation. And then what we do is we look at a time here, say 100 seconds, and then in the blue one here, let's say blue is A, then I look at other times where B has approximately the same value. Well, yes, here there is, and here there is. So that means at 100 seconds, I would put a dot here, and I would put a dot up here. I don't know if there are actually dots there, but that's what I would do, right? And so this is called a recurrence plot, or a cross recurrence plot. And it actually shows you that there are two different regions of the data. So what happens, so if we do this, and say the data follow each other exactly, then we just get a diagonal line up here, right? So we have, it only recurs at the same time, and it happens at the following time, the following time, the following time. So if you have the diagonal going up here, that means the two time series here are completely identical. But what we see is that the recurrence plot is segmented into this region down here and this region up here. And these blue lines I put in are not lines I put in after I saw that there's this nice segmentation. They're actually the exact time. So it's about what, 35 seconds here, 35 seconds. It's the exact time when we noticed in the video that the experimenter said, okay, now I'm ready to give you instructions. So we see that we can actually, even if we didn't know that, it's pretty clear that something happens here, that we have a region here and a region here, and they're qualitatively different. So we can look at all these nice plots, and it's fun, and with a bit of training you can actually learn to interpret them, but there's also a way to quantify them. So you can measure the amount of points in diagonal lines and the length of diagonal lines, and you can take the maximum length and the average length and compute entropy measures and a lot of other stuff. So we get all these nice quantitative measures from this plot. By the way, I just want to show you what happens if I take two. So now I'm going to keep one of the persons and change the other one, right? So it looks relatively similar. Not a lot of change here and here. So I have these three different ones, and they basically all give more or less the same story. So this also gives us confidence that we can actually look at diets as a relevant unit of description and then aggregate it to a group level. And so this is what happens. I'm not going to spend a lot of time on this, but this is what happens if you take a larger. This is actually production period 1, 2, 3, and there's a pause, 4, and 5. And again, we have 3 sets of diets, and that gives us 3 different recurrence plots. And we're mostly concerned with what happens inside these smaller rectangles here. But this is how we analyze the data. So we put this plot. We didn't really plot it all the time, just to make nice graphs like this. But we just did the quantification. So we had a computer analyze the plot, so to speak, and come up with these quantification measures. So what happens? Just forget about the text here. We, from the questionnaire on group cohesion, or how they perceive the group cooperation, we took out 3 factors. One is, by looking at them, we sort of tried to give them names. So we called this factor 1 positive affect towards the group. So this is like, I like the other persons, I really, it was enjoyable to work with them, and so on. And this is positively correlated with synchrony of smiling. Not surprising, right? But it's kind of fun to see it come out of such a complicated analysis. Factor 2, which had to do with tensions within the group, like there was one question like, I felt held back by the other members in this group, or I could have done better on my own. That was correlated with synchrony of skin conductance. So skin conductance, if there's high synchrony among the individuals in a group in skin conductance, that seems to be an indication that there are tensions in the group. So this is something we didn't expect. We thought, okay, synchrony is good, but actually we see 2 different kinds of synchrony. So synchrony of smiling, that seems to be positively related to good things, whereas synchrony of skin conductance, which could be like a stress response or arousal thing, that is correlated with negative stuff. Okay, this is the decision. Here we have the ones that actually did not use the new routine. So they go. No, wait a minute. Those are the ones that did. They go down in synchrony in skin conductance. So in a way, you can say they get better group dynamics, and the other thing happens for those. But we see that this is pre and post decision. So it's really the decision that drives this. So there's no prediction in this. Whereas when you go to smiling, there's actually a possibility here. Here we have, and again, notice that, positive effect and negative effect, the 2 different manipulations, they're basically the same. which is consistent with the fact that we're not able to split them up, right? But we see differences in positive and negative effect when it's synchrony of smiling, and here we could use this synchrony here in smiling to predict the decision that we're going to make. Not perfectly, mind you. We had like a 65% success in prediction, so it's not like a fantastic model, but it seems to be an indicator that more happy groups, or it's not actually happy, it's the ones that smile and sync, seem to have a higher chance of making the right, or the best, in this case, decision. All right, I think I'm going to have to wrap up here. So let's see. Yeah, this is the third thing we did. Can I have you spend 30 seconds on it?
You got 30 seconds, yeah.
Yeah, okay. So now we did individual stuff, aggregated that to the group level. We did diets, aggregated that to the group level. And we weren't really happy with that. So we actually developed a new method. So this is Sebastian Ballard, Andreas Ripsdorf, and I, called multidimensional recurrence quantification analysis, where we can take not only two, which is what people mostly do, but we could take all three people, stick it in an analysis. I'm going to skip this. I just want to show you here that this is normal recurrence, and this is prediction of performance, like how many boats they made, good quality boats, bad quality boats. And the significance is around here, like just below 0.1. So it looks as if when we go from aggregating from smaller parts of the group to doing everything at a true group level, we actually get, this is in a linear regression, we actually are able to predict the performance, something we could not do with the other kinds of data we had. Okay, that's it. So classic aggregation, not very useful for these kind of data. If we do it based on diets, it's better. But the best thing is really to do true group level dynamics at the outset. But this requires new methods, and we've started to develop those. And that seems very promising, and we're going to use that in the future as well. Thank you for your attention.
Perfect. Thank you very much, Ben.